management through the visualization.
All right, thanks for having me. Let's get this going here. Well, again, my name is Doug. I'm actually here on annual leave today, and so my federal ethics folks require me to state that because I'm not representing an authority, the Bureau of Reclamation, that this presentation doesn't reflect the Secretary of Interior. Thank you for bearing with me on that. I should have actually written it down there. It's just something I have to work with. But anyway, at that though, I'd like to introduce this topic. It's the Gila-Salt-Verde river system, improving river forecast for emergency management through visualization. And I have to thank the folks at the MGIS program with Penn State, Dr. Reed, especially Dr. Josh Kalat, and Dr. Doug Miller. They have been great supporting this, and essentially what this is a presentation on how to maybe utilize fusion tables to enhance visualization related to decision support systems on some of the existing web-based applications you have on the internet. So I'm just going to go over a little bit of background on the Colorado River system. I will go over operations and emergency management forecast web apps that we usually use. I'll talk a little bit about visual analytics, and then go into objectives and talk about methodologies. And the objectives really, again, were to enhance the existing web-based applications. The methodologies was to take this new idea or this kind of like this beta testing idea that Google has, their API with their fusion tables, and see if I could put it to good use. So the Gila is a major tributary to the Colorado River system. It flows through southern Arizona. We have dams that provide water supply for Phoenix, but the dams also provide flood control. And as most of us know in the industry, the water supply is covered by the Salt River Project, but the U.S. Army Corps of Engineers usually handles flooding. And so there's kind of a dual mission there. But both of them work together to provide protection for the folks of Phoenix downstream of the dams and in other places throughout the country, at least the Army Corps of Engineers. And so the forecast is important just to manage the resources. If you have a rainstorm event or any sort of precip event, like a rain on snow or some sort of pulse onto this SRP system, you want to know what that forecast is. You want to manage your dams accordingly. So here's just the Colorado River Basin. As I'm not sure how much you know about the Colorado River Basin, but essentially it's just broken into the upper basin here, the lower basin here. There's a compact point right downstream of Glen Canyon Dam right here, and essentially water and snow melt driven runoff comes off the western slope. It drains down to the Colorado River, to the confluence of the Green River, comes down into Lake Powell, impounded behind Glen Canyon Dam, released from Glen Canyon Dam, then through the Grand Canyon into Lake Mead and Hoover Dam, released from Hoover Dam, and then down through the system where it supplies water out to the Southern California coastal plain, out to Phoenix and Tucson, and then down to the irrigators in the Imperial Valley, and then also to Mexico. And so Gila is right here. So that's a kind of tributary in the lower basin, which is important at times, depending on how wet the water here is on the system. And so now we're just drilling down just a little bit more. This is Arizona here. This is New Mexico. The Gila watershed again is western New Mexico, down to the Verde, the Salt, the Gila, draining into the Colorado River right here, right at Yuma. And this is important for in terms of decision support. Usually this is exceptionally dry down here, south of or downstream of Painted Rock Dam. It is so dry that it's so sandy that if there is any releases out of Painted Rock, it can just essentially just sink into the sand before it even reaches the Colorado River. But occasionally, especially on El Nino years, and I think we have an El Nino event coming up perhaps this next year, the forecast, we have a 78% chance of an El Nino year, which means that there could be some heavy precip in the lower basin this year from from the water coming in off the Pacific, that actually flows will be released from Painted Rock Dam and get into the Colorado River system. And so what happens, that's when the decision support really takes place on the entire Colorado. We have the operators, basically on the Colorado River, if they have deliveries here at the Gila for Mexico, essentially will try and back the system up and try and keep all the water into Lake Mead. So what they do is they'll cut flows at Parker, cut flows at Davis, and then reduce the energy targets at Hoover Dam in terms of a run-of-the-river type of operation scenario, in order to just save the water in Lake Mead. Every drop seems to, or acre foot seems to count these days because of the drought. So anyway, there is a dynamic that goes on right there with the confluence of the Gila. And then, of course, we're dealing with the Salt River system here in the Salt-Verde. So we're drilling down just a little bit further. We have several dams. There's Painted Rock right here. And let me just page through these. There's Coolidge down over here. We have Stewart Mountain, Mormon Flat, Horse Mesa, and Roosevelt, and Bartlett, and the Granite Reef Diversion Dam. And so those dams there are basically the system that is in place that is kind of the focus of this fusion table and this decision support system. All right. So now I want to kind of migrate over to web-based applications. So how do you manage the system? When you have a rain and snow event or a snow melt or a rainfall event, what happens is you go to your website and you're the operator, you want to know what's happening. What's that hydrograph look like coming into my dam or onto my gauge? Is it going to flood out in Phoenix? Is it, what's basically going on? And so one of the web-based applications we look at is this CBRC Google API. And what this is, we're looking at here, is I basically drill down into their website. It's a Google API web interface that is at real time and shows gauge information. It basically brings in USGS data, but most importantly also they model that data, where they run a model, several models, up in Salt Lake City, or here, or close by here. I'm from the Lower Basin, obviously, so I say up in Salt Lake City, but they'll run models like such as the Sacramento Soil Moisture Accounting Model, the SAC-SMA, and develop hydrographs based off of that in terms of the forecast. And so what you're looking at in terms of an operator on the system is a forecast that is this modeled hydrograph coming into the system to see exactly what's happening. There are other web-based interfaces that we look at. This is the Army Corps of Engineers Painted Rock Dam web interface. Is mostly a spreadsheet, but just brings USGS data in. But there is, importantly, no real forecast with it. The Corps is just kind of taking in and reprocessing USGS data for use for Painted Rock Dam, but they're not running models like CBRFC, so you can't really see what that forecast is in terms of the pulse coming into the system. And then this is SRPs. It's another web-based interface. They're all kind of looking at the same system. It also pulls in USGS data, but also has information related to operations on dams, such as the Stewart Mountain or others, Roosevelt Dam on the SRP system. Excuse me, sorry. So in terms of all this and visual analytics, we're looking at basically just information visualization, scientific visualization, analytic reasoning, just any sort of facilitated or interactive visual interface that can help us in terms of operators and decision making, make decisions from kind of like that human-machine interface that you have when you've got to make quick decisions kind of on a hierarchy basis, especially related to pulses coming into dam systems or any other releases that you might make, or the whole dynamics of the entire watershed. So the goal is to process data for analytic discourse and create constructive evaluation, correction, or rapid development of processes and models, and ultimately improves your knowledge and decisions. What I was hopeful to do was to develop something like a Google Fusion Table API, which might work, which would be customized for the Gila-Salt-Verde system. I'm not sure if it was quite as sophisticated as what we had at CVRFC, but it was a good attempt. We took the concept of visual analytics. We tried to bring things together in terms of the Fusion tables and all the different web interfaces we had through links. And we tried to look at operational efficiencies with the SRP and the Army Corps of Engineers. So again, what we did is I developed a mashup, which was given to operators at the Bureau and also at SRP. Again, it was a Google API. We kind of looked at sent a questionnaire out to the operators to see if this might help out in terms of their decision making on the systems, and generally we got a pretty good response. And so this mashup that we developed essentially was from Coolidge all the way down to Painted Rock Dam. It was again supposed to be customized for the SRP and USACE, the Corps. And essentially what we did is I used a Fusion Table Wizard, which had 4 layers to it. And these are the 4 layers. One was a USGS Arizona Gauges layer. Another was a Gila-Salt-Verde watershed layer. There was a Select Dams layer and a Select Gauges layer. And this is what it looked like. And let me, bear with me here. I think I can, excuse me. I think I can actually bring the Fusion tables up so we can take a closer look. This is what the Fusion tables actually look like in real time, and this was the end product. It's a little bit interactive here. The 4 layers I created were, again, the Select Dam layers here, the Select Gauges, the Arizona Gauges, and the Gila-Salt watershed layer. And each of these can be selected and basically query through the Fusion table. If I wanted to say find Bartlett Dam, this would be Jan on me. I might be able to focus in on Bartlett slowly. Each of these gauges here, for example, well, let's see what I can do to speed things up here. There we go. Okay. So I have 4 layers here. Each one is a Select Dams layer. Those are what you see here in blue, and then there's a Select Gauges layer, which is you see here in orange. Then there's also a Arizona Gauges layer, which are these small dots here. And there's also a Gila watershed layer, which is the chloroplast, which you see right here. The table itself was created simply and easily, and that's kind of one of the neat aspects of using Fusion tables, is that the Fusion tables are pretty easy to create. This was simply a CSV file from an Excel extension. All you needed really were 3 columns to start out with the CSV file. This is the map of the Gila-Salt-Verde Dams layer. We just looked at one of those layers. So at least you need a lat long, you need your geospatial reference to start out from. But in this case, what I did is I added on columns, and these columns were an image column, facility information, and operations data. What I've done with the Fusion tables essentially is I've used the Google API to bring this information into the info windows from the markers within the Google API. To that end, you can take a look at the map part of this. The Fusion tables have, usually when you bring them up and create them, you have either rows, cards, or a map tab to work from. This is the result of the map tab of what you see from the columns essentially mapped out. Coming in off the cloud here. Yep. So we basically have created this map from that last table we saw. And this would be the result of that info window we talked about in terms of bringing the column information in terms of facility information and operations data. So you can do a lot of things with this. You can basically change the info window. You can change the center styles here. You can use different icons. You could convert those into like a green icon if you really wanted to, or if you wanted to change the info window, you can customize the info window. And essentially, right here is your HTML coding that goes in as part of the customization for the info window. Okay, we're almost done. And this essentially just brings in these columns here again: the dam, the lat long, the location map, the image, facility information, and operational data is basically just brought into the info window from this coding you see here. So at that, what you do essentially with this to create the different layers and to create the final fusion table is you publish this, and it gets published through this tools publication right here. You come in and you basically get a link. If it's kept private, you have the option of not publishing it. You can basically go in and make this public. You can take this link here, copy it over, and then bring it into something called the Fusion Tables Layer Wizard. Take this, add it into the wizard, and nicely changed my markers to green for me, and create different layers. So I can add, for example, another layer. I'll just add the same layer just because I had copied that one layer. So I can add the layer to the map. Now I have another layer, and I can add a search tool. So what happened here was that I added this layer to the map, and then I added the search tool. And the search tool comes down here. Basically, it's a text-based search. So if I were to type in something like Mormon Mesa, maybe that would come up, maybe not. Let's see. Yeah.
It'll be Mormon Flat.
Mormon Flat. Maybe that's why it's not coming up. Thank you. Mormon Mesa is a mesa outside Las Vegas. I knew something was wrong here. All right. Well, it should, if I had a faster internet connection, perhaps. But you can also do a select base where you don't have to type in any search, but you can just basically have a pull-down menu with Mormon Flat. Thank you. So anyway, that's it. That's essentially Fusion Tables 101. What happens in the end was you take those 4 layers, you put them together, and you end up marrying these 4 layers together with these pull-down menus, which we'll see if we can get a quick response, say with Bartlett. Maybe, maybe not. Yeah, but you marry these up, develop layers, have something quick. It's not nearly as sophisticated as say the CBRC. I'll readily admit that. But if you want to do something quick and customized, it's an easy thing to use. So, that question?
What you can say about the session?
Okay.
Additional questions? One question, anybody?
Questions? Questions from Messer?
Thank you.
Thank you.
So our next speaker is Mr.